Okay, so function operations. Some of this would be review from Unit 0. However, we are going to learn about a new operation. But first, let's review inverse functions. An inverse function is a function that undoes another function. We particularly use the switch and solve method, again, which is where we utilize the switch and solve method of finding inverse of a function. We switch x and y in the original equation, resolve for y. The answer yields the inverse function. We're going to go through a couple example problems here just as a review. So if I'm using the switch and solve method here, I would switch my x and y first. Again, f of x is function notation for y. And now I resolve the function for y. Remember, as far as resolving, start from the outside in. All right, we'll always work outside in. Always start away from the variable and work towards it. Just a few hints as you try to determine what steps come first. So x minus 4 is just x minus 4. All right, next step, divide by 2. I'm not actually going to divide anything by 2. I'm just going to leave it as x minus 4 divided by 2. And that's going to equal y minus 1 squared. Okay, and then to cancel the square, I'm going to square root both sides. So square root of x minus 4 over 2. I can't actually square root any of that, so I'm just going to write it as y minus 1. And then finally, I would end up with my inverse function. I'm going to write it back over here. Inverse of f of x is going to equal square root of x minus 4 over 2. You can put that in parentheses if you want to, plus 1. And that would be my inverse function. So everything there should be the opposite of what's being done to the x in the original function and also in the opposite order. Here's another example of the finding an inverse. Again, the switch and solve method. Now this is one that we saw in Unit 0. We didn't talk too much about. All right, but sometimes when we switch x and y, we end up with two y's. To eliminate the fraction, I'm going to turn the x into a fraction and we're going to cross multiply. So I'll get xy minus 1x, and that's going to equal 1 times y plus 2, which is just y plus 2. Remember, if I'm solving for y, the first step would be to group that variable. So if we want to group the y's together. So to do that, I would have to subtract a y from both sides. I'm going to add this 1x to both sides. So when I do those steps, I'm going to end up with xy minus y, and that's going to equal 2 plus x. Now here's the trick with these, okay? When I have two y's, I'm not going to be able to solve for that. So when I look at this, I should notice that I can undistribute this y, okay? The F word in math class there would be factor the y out. So if I do that, I'll end up with y times the quantity x minus 1, and that equals 2 plus x. Now solving for that last step to get the inverse is simple. My inverse of f of x is going to be 2 plus x over x minus 1. Now this just happens to be a situation where the inverse is equal to the original function. That's called a one-to-one function. Special case. Doesn't always happen that way. And last we have one more inverse. Okay, so again, just practice here, trying to show you, some of the possibilities that we can get. And I wanted to touch base on this in particular because we talked about this in class a little bit today, and that was the 1/2 power. Remember that a fractional exponent is nothing more than a root. So if it makes you feel better, you could rewrite that as the square root of y plus 1. That is the same as y plus 1 to the 1/2. So to get rid of the 1/2 power, I'm going to square both sides. So I will have x over 3 quantity squared equals y plus 1. And finally end up with my inverse of g of x equaling x divided by 3 quantity squared minus 1. Again, it should be the inverse operation and in the opposite order. Now we're going to talk about a new operation here for functions, and that's polynomial division. Polynomial division is no different than long division. So if you remember how to do long division from way back when, this will come very natural to you. I'm going to teach you to set it up like a long division problem. The only thing that I would like you to do though, is leave a blank where we would have missing terms here. So there's no x term. So I'm just going to leave a blank there. All right, and then I'm going to put my x minus 3 here. That's my divisor. Now, the same as long division, I'm trying to ask myself, what would I have to multiply x by to get x cubed? So I'd have to multiply by x squared. And I always want to make sure my degrees are lined up. So I'm going to write the x squared above the 2x squared. And then I multiply. X squared times x is x cubed. That's what I want. If those two are not equal, I'm wrong already. I choose this. X squared times negative 3x is negative 3x squared. And now I subtract. And I'm subtracting the quantity. So the x cubes cancel out. That's what we want. But the negative 2x squared minus a negative 3x squared turns into addition, which leaves me with a positive x squared as that remainder. I would bring down my next piece, which in this case is a blank, so I leave it go. And then I determine my next one. So what would I have to multiply x by to get x squared? That would be an x. So x times x is x squared. X times negative 3 is minus 3x. I'm subtracting the quantity. So the x squared minus x squared cancels. The blank, or the 0, minus a negative turns into addition. I get 3x. And then I bring down my minus 4. And my last step here, or what appears to be my last step, how do I obtain a 3x with an x? I'd have to multiply it by 3. So 3 times x is 3x. 3 times negative 3 is negative 9. Subtracting the quantity again. 3x minus 3x cancels. Negative 4 minus a negative 9 gives me a remainder of 5. How do I write my answer?
Please, Marcia.
I write my answer x squared plus x plus 3, and then I need to add my remainder. It's no different than writing a mixed fraction when you divide it by 4. Okay, you're going to add the remainder to the divisor. So it's going to be plus 5 over x minus 3. And that would be my answer. So x minus 3 itself would not be a factor because it does not divide evenly. It divides, but it doesn't divide evenly because I ended up with a remainder in the end. I want you to go ahead and copy down the next example and then try it on your own. And then when you push play again, it should be there for you to view the answer. So my answer here, again, 2x goes into 2x cubed. X squared times 2x gives me 2x cubed. X squared times 3 gives me 3x squared. I subtract these. 7 minus 3 is 4. Bring down my 2x. Two x times 2x gives me 4x squared. 2x times 3 is 6x. I subtract these. I get negative 4x. Bring down my 9. Negative 2 is negative 4x. Negative 2 times 3 is negative 6. 9 minus a negative 6 turns into adding. That gives me a remainder of 15. Last example here for division. This is a doozy. Is x minus 4 a factor of that big, long polynomial? Right? The only way to know that, or one way to know that, will be to divide the 2 and then determine if it is a polynomial or not. So after taking a look at that and completing the process here, x times x4 is x to the 5th. x4 times negative 4x to the 4th. Subtract those, I get 2x to the 4th. Brought down my 8x cubed. 2x cubed times x is 2x to the 4th. 2x cubed times negative 4 is negative 8x cubed. I got a remainder of 0. Because of that, I brought down the next two pieces, the 3x squared and the 17x. And negative 3x times x is negative 3x squared. Negative 3x times negative 4 is positive 12x, remainder 5x. Bring down the minus 20. 5 times x is 5x. 5 times negative 4 is negative 20. Remainder of 0 is what tells us that, yes, x minus 4 is a factor.